In chapter 5, we learned about the definite integral. That's an integral symbol. It has a lower limit and an upper limit and an integrand. And we said that it came from wanting to have a notation to say I want to find the area under the F curve between A and B. Notice that A and B in this case were x values. They're inputs to the function, A being the smallest or the leftmost input and B being the rightmost input. And that notation came from noticing that if I was going to use vertically oriented rectangles to sort of break up that area, that I would be multiplying the area of those rectangles. I'd multiply a function height, so like an output value, an f of x value, times a very small change in the width of the rectangle, a very small change in x. Here, we use a new notation that sort of expands on the idea that we use an antiderivative sometimes to evaluate a definite integral. So now, if I want to solve a differential equation, meaning if I want to find a function whose derivative I know, I use this same notation. We call it an indefinite integral because we don't use any limits. This is the notation for an indefinite integral, and it means report to me an antiderivative for f of x. So here's a first example. This says, find the antiderivative for x squared minus sine of x. So I'm going to use this notation. I'll write all out. The antiderivative of x squared minus sine x is, an antiderivative for x squared is x cubed over 3. An antiderivative for negative sine of x is positive cosine of x. And because I don't have enough information to figure out if there was or was not a constant attached, I include what we call the constant of integration. There might or might not have been a constant there. So there was a constant there, but it might have been 0. So since I don't know what it was, I'm going to report a plus c here to say this is the family of all functions whose derivative is x squared minus sine x. So at this point, I often get the question, does it matter if I forget the plus c? It absolutely matters if you forget the plus c. If you do not remember the plus c, you will not get full credit. And it's going to really throw you off for any next steps that happen to come. Important indefinite integral fact number 2. We only know how to evaluate integrals that contain one variable. That holds until you get to college and take a class called multivariable calculus. But in all of AP Calculus, even Calculus BC, we only deal with integrals that contain one variable. So example 2, we can do. It says find the antiderivative of 1 over 1 plus x squared. And we know that that is inverse tangent of x plus a constant. Notice I could have asked this question with a different variable. You know how to find the antiderivative of 1 over 1 plus p squared dp. That's inverse tangent of p plus a constant. So it doesn't matter what the variable inside your integral is. It just matters that there is only one variable. Any variable in that function must match this sort of variable of integration. We sometimes call it the dummy variable. But look at example 3. If I ask you to find the antiderivative of 1 over 1 plus x squared dt, that kind of implies finding the antiderivative of 1 over 1 plus x squared with respect to t. But those variables don't match. I can't do this. This cannot be evaluated. So you're never going to see something like that on the AP test. They won't mess around with you and give you an integral that has 2 variables in it. But I'm warning you because we're about to write integrals with different variables in them. We're about to try to change the variable that we use. And you can't actually go through that process of trying to find an antiderivative if there's more than one variable in your integral. So It's not that you would ever see this on the AP test, but you might see it in your work in this section of the chapter. And if you looked at that and tried to actually find an antiderivative, I'd want you to stop and notice and say, oh no, I can't actually find an antiderivative because there are two variables there. Okay, so let's talk about integration by substitution. So far, we know how to find antiderivatives by using the inverse power rule. So like the reverse power rule, add 1 to the exponent and divide by the new exponent. That works for functions that are polynomial. But we don't, and we also know how to find antiderivatives when we recognize the derivative formula. Like recognize as our integrand, something that we remember back from when we were taking derivatives. Some of them are harder to remember and recognize, so the better you know your derivative formulas, the easier this will be. But even if you know all of your derivative formulas by heart, there's several classes of antiderivatives that we don't usually recognize by sight. So this technique is called integration by substitution, and it helps us turn an integral, like a function whose antiderivative we don't know just off the top of our head, into one that we do. So look at example 4. Oh, here, don't forget this important reminder. We're going to be changing the variable, for example, in this integral. Right now, I see evaluate the integral of e to the 7x dx. That integral only has one variable. I don't know the antiderivative off the top of my head, though. So I'm going to go through a process where I'm going to change the variable using a substitution. And I'm going to make sure that at the end, I don't try to finish my problem with 2 variables left inside the integral. I'm going to have to make sure I get down to 1 variable before I try to find an antiderivative. So here's our process. I notice I want to find an antiderivative of e to the 7x. And there's not a function I can think of off the top of my head, maybe, that has the derivative e to the 7x. But I recognize this function a little bit. It's kind of like e to the x. So this is what I'm going to do. And we'll talk more about how to choose your u in the next several examples. I'm going to make what I call a substitution. I'm going to let u equal 7x. It's that 7x that's giving me a problem. I know how to find an antiderivative for e to the x, but not e to the 7x. So if I let u equal 7x, then I can imagine taking the derivative of both sides with respect to x. I might say du dx equals 7. I'm going to try to isolate the dx because I'm going to make a substitution in for that dx. So you might say du equals 7 dx. I'm going to divide both sides by 7 now and get that dx is du divided by 7. So check this out. I'm going to rewrite the original integral, but I'm going to use some colors just to kind of help you see what happens here. And e to the, I'm going to write 7x in red. And I'm going to replace that dx with a purple dx. I can use these substitutions. I can use these expressions here to substitute into my integral and change it into an integrand that I actually know an antiderivative for. So this is going to be e to the, what can I use in place of 7x? In place of 7x, I'm going to use u. And what am I going to use in place of dx? I'm going to use du over 7. So I wrote a new integral. It's exactly equivalent to the old integral because I've made these substitutions that are exact substitutions. Now, at this point, you can evaluate this integral using a couple of different steps. I like to notice that if I'm going to divide by this constant 7, that's a constant multiplier. So I'm going to factor that 1/7 out to the front, and I'm going to get the integral of e to the u du. Well, that's pretty easy. I know the antiderivative of e to the u with respect to u. That's e to the u plus a constant. Notice I have the 1/7 multiplier here. And that I can check. No, I can't check that. Sorry. Let me try it again. This is a pretty good answer, except the original problem was written in terms of x, which means I have to give my final answer in terms of x, and right now my answer has a u in it. So I'm going to make the substitution back the other direction and say that anywhere I see u, I'm going to write 7x. So my final answer, 1/7 e to the 7x plus a constant. And how can I check my answer to an antiderivative problem? I'm going to take the derivative. So I'll ask myself, what's the derivative with respect to x of e to the 7x? That's e to the 7x times 7. Notice that 7 will multiply with this 1/7 to cancel out. And derivative of c with respect to x is just 0. And I get back my original integrand. This is integration by substitution.